Okay, hello everybody. Uh, Before starting our lecture today, I want to check if you did the homework and the quiz at home. Oh yes, I should like a recording of our class. Sorry. Okay, record it. Okay. Oh, okay. Uh, so last time I gave you many instructions regarding how to, for example, check your grade, for example, how to submit your homework, right? Uh, it seems that there were several students uh, just joined our class this week, okay? So for those who missed the first lecture, please um, read carefully my instructions here in our groups page, okay? And last time I gave you at in class the quick quiz one. You miss it. However, we have homework number one and quiz to do at home number one, and they are still available, right? You still have time to do it. So please, if you join our class lately, please do it quickly. Um, for example, here we have quiz at home number one, and we have only 9 students submitted their work, right? So uh, I don't know why, but be careful, right? Take take care of the deadlines of the homework and quiz to do at home. Okay, only 9 students did their quiz. Let me see the homework. For the homework, we had 12 submitted. Uh, so I just want to remind you that uh, please check carefully the deadline, for example, here, right? Uh, yeah, the deadline is here. So you can see you have nearly 1 week to do it. Uh, the deadline will be on Thursday. Similarly, the quiz at home also Thursday. That is the deadline. Okay. I wrote reminders. Uh, I hope that you got my message. Okay. Again, after our lecture today, on Thursday, I will give you a quiz to do at home as well as homework. Today, we move on to the first part of mechanics, and in particular, it is called kinematics. Động học. Okay. Uh, so In the first chapter, chapter 2, we will study motion in one dimension. Okay. Motion in one dimension is the motion along only one line. For example, you have uh, a ruler, a line, right? And you have a bug, a ladybird, for example, or an ant, and it crawls along this line only to the left and then to the right and then on to the left, for example. So that is the kind of motion that happens only along one line. Okay. In order to describe such motions, you only need one variable for its position. That is, for example, you call it x. So you look at the ruler, for example, something is moving here, you have an origin here, you look at the ruler, you say the ladybird is at 6 centimeter away from the origin, for example. So you don't need to use y, for example. You don't need to use z, right? You just need one variable for its position, that is x, for example, or you can call it L, S, for example, whatever, but only one variable for the position. And that is motion in one dimension or one-dimensional motion, the simplest form of motion that we will start to consider. Before going any further, I want to give you a picture about kinematics. Động học, okay? This is kinematics. So what is kinematics? Kinematics is a branch of physics that studies only the motions of objects, okay? And we ignore the interactions that cause or change the motion, right? In other words, we describe how things move, right? For example, how long does it take to go from here to there? How fast does that move, right? And what kind of orbit? Is it a line? Is it a circle? Is it an ellipse, for example, right? How things move. That is the main concern of kinematics. We don't care about the reasons of that motion, right? We describe how the earth is moving around the sun, and we don't care about why it is moving. Okay, it seems that I forgot to share my screen, right? I forgot to share my screen. Yeah, sorry for that. Yeah. Next time when I forgot to do something, please quickly turn on your microphone and tell me, for example, right? Thank you. So we are talking about motion in one dimension and kinematics, okay? And I am giving you some example, like we describe how the earth is moving around the sun, right? How long? 1 year. How fast? You can calculate or you can observe the velocity of the earth around the sun. You don't care why the earth is moving around the sun, why the earth is not moving away from the sun, right? These things are the objects of another branch of physics, which is dynamics. Don't look up, okay? In dynamics, we use Newton's laws to consider the reasons why things move this way or that way. We care about force, we care about mass, etc. Right? Right now, at the very beginning, we only care about how things move. That is the way that our ancestors actually did at the dawn of human beings, right? As I said in the previous lecture, the most ancient kind of science or physics is astronomy, thiên văn học. What do we do in astronomy? We observe how stars move, right? How the moon is moving, for example. That is exactly kinematics. At the very beginning, we didn't know Newton's laws. We didn't know where, how, why the planets are moving in that way. Right? We explain everything by saying gods. We have gods of the planets. We have Jupiter. We have Saturn. We have a lot of gods that govern the motion of the planets. Right? At that time, our model was gods, a collection of gods, and that was the only ability of explaining why. However, we could describe very well how things move, right? And that is kinematics and astronomy, right? After several chapters, we will move on to dynamics, but here we will only talk about kinematics. Okay, these are different. The difference between them. One answers the question how, and the other answers the question why. Okay. Okay. Uh, for motion, we have several kinds that we can divide motions into. The definition is very simple. What is a motion, right? Motion is the change in the object's position. Okay. In the morning, you are at home, and 2 hours later, you are at the university. So there was a motion, right? That is the change of the position. We can divide motions into three kinds, three independent kind of different kinds of motion. The first is translational, chuyển động tịnh tiến, okay? The second one is rotational, and the third is vibrational. We divide them into three kinds for later studies. And then we will talk about the definition of what of these motions in order for you to have a picture of each of them. For the translation motion, you can think of a drawer, right? Ngăn kéo. When you push it or you pull it, the motion of a drawer is kind of translational. Okay. If you have a wheel and you rotate it in the air, please remember in the air, you have a rotational motion. Rotational motion. Okay. For example, okay, and I will tell about the next one, and then I give you an example. The third type is the vibrational, dao động, vibrational, and it is characterized by the existence of one special position, which is the equilibrium, điểm cân bằng, and our object is moving back and forth about that equilibrium position. Okay, for example, the pendulum, as you know from high school, you have a mathematic pendulum, or you have a spring pendulum, right? So these are the three types of motion. Okay, now I have a pencil. Okay, okay, it's this color is too bright. I have this. Oh no, I will use this one. Okay, this is my pen. If it is moving like this, okay, that is translational. Okay, translational. If I do it like this, see it? This is rotational motion. Okay, and if I put it like this, it is in vibrational motion. Okay, or it can move like this. It is also vibrational motion. This is the equilibrium position, and it's kind of moving back and forth, right? That is translation. That is vibrational. Okay. kind of a short definition. Actually, I should describe it in a more formal way so you can distinguish between the three types. Okay. Sorry, I will turn off my phone. Okay. For example, you have an object like this. You have a box, for example, right? Now uh, you have it sliding, right? For example, it is sliding like this, right? And some points of it create the lines like this, the gray lines like this. Okay. In order to 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 know exactly that this is a translational motion, you can do a trick like this. You pick 2 points on the object. For example, you pick A and B, right? And then in every different position, you you draw a line again. For example, I had a line AB here, and after some time, its position is here, and I draw again the line A prime and B prime. And I look and I see that they are parallel. Some. They are parallel to each other. Every time I see, every time I check, they are parallel, right? And so what you can see here is that even though our object is not moving in a straight line, right? But it is still in a translational motion. Okay, the translational motion is a kind of motion in which if you draw a line between 2 points, it will be parallel to itself, right? It can move in a curved way, but they will be parallel to each other all the time, and you call this translational motion. Okay, the drawer here, I gave you an example of a drawer, and this is a special case, right? The drawer only moving in kind of one line, right? But in reality, you can have translational motion even though it is not moving in a straight line. Okay, the important thing here is definition like this, right? However, if after some time you see this line is not anymore parallel to a B, you see and you know that there was some kind of vibration in this motion. Okay. So if after 1 second, A prime, B prime is no more parallel to a B, you can say for sure that there was some rotation motion. Okay. For example, this is my pen again, right? This is my pen again. At the beginning, I picked 2 points, which is the two tips of my pen, this one and this one, right? At the beginning, it is this in this direction, but after some time, when I rotate it, it is in this direction, and you see that they are not parallel, right? Okay, so this is a rotational motion. Okay, I will give you another example of a translational motion. This is my pen, and it goes like in a straight line. This is translational motion. However, it can move in this way, up and down, up and down. However, every time you see the pen is parallel to itself, and therefore this is also a translational motion. Okay. And what about vibrational motion? The trick here is look at it, and you will see for rotational motion, you will see the existence of one equilibrium point, and our object is moving back and forth. We go around that point. Okay. Okay. And I have one question for you, and you can answer my question to earn some, bonus. The question, well, I think I will ask someone because last time actually there was several students only who answered my question. So this time I would call your name. Actually, I want to call out your name. Please wait a little bit. This is 02, and here I have your grade book. Okay. Okay. My first question is what is the kind of motion of the wheels of a moving car? Bánh xe, cái bánh xe khi mà cái xe nó di chuyển trên đường thì cái bánh xe nó chuyển động của nó là chuyển động gì? Okay. Okay. Now I will ask someone. Okay, let me see. Do we have girls here? I don't know. Okay, I will call for example Đinh Tuấn Long. Đinh Tuấn Long, are you here with us? No? Great. Okay. Sorry, do we have girls with us? Do we have female here? Do we have ladies? Or we only have boys? Okay, it seems that we don't have any ladies here. I would call Nguyễn Thanh Minh Triết.
I'm here, teacher.
Okay. Please answer my question.
Dạ em trả lời bằng tiếng Việt được không ạ?
Yes, it's okay.
Dạ, thưa thầy là bánh xe di chuyển theo chuyển động tròn ạ.
Chuyển động tịnh tiến, chuyển động lăn, chuyển động tịnh tiến, chuyển động quay và chuyển động dao động. Which kind?
Dạ, quay ạ.
Okay, thank you. Okay, I have Phạm Văn Cao. Phạm Văn Cao đúng không? Okay, Phạm Văn Cao. Okay. Yeah, that was correct. So here we have a combination of thank you the others. That was the correct answer. So for the wheels of a moving car, we have the combination of translational motion and rotational motion. If you have a wheel in the air, right, its motion will be kind of only rotational. However, when our cars are moving, all right, if you look at different points of our wheel, actually they are moving in kind of a combination of translational motion and rotational motion. The translational motion is the translational motion of the center of mass. Khối tâm di chuyển tịnh tiến cộng với lại di chuyển của các chất điểm nó di chuyển tròn xung quanh cái khối tâm đó. Okay. So you can look here. You see, we have a point on the rim of a wheel, and when our wheel is rolling without any skidding or slipping, that point draws a line called the cycloid. Okay, that is the cycloid. Okay, so it is not like a circle, right? It's not a circle. This line is called cycloid, and it is the combination of the rotational motion and the kind of translational motion. Okay. Okay. Now I have the other question, right? You know, a Ferris wheel, cái vòng tròn trong công viên á, Ferris wheel là cái vòng tròn đó. So if you look at the people sitting in a Ferris wheel's cabin, which kind of motion are they in? For example, I will show you the Ferris wheel here. Okay, it looks like this. This is, I think this is the first ever Ferris wheel, right? It is rotating. I mean, the whole Ferris wheel is rotating with some constant angular speed. If you are in a cabin, so what kind of motion are you in? Are you in rotational motion, or are you in translational motion, or are you in kind of vibrational motion? Phan Thế Khải, Phan Thế Khải, please. Phan Thế Khải, you want to answer my question? No? Okay, I don't hear anything. Okay. Uh, I would call, let me see. Nguyễn Hữu Phước.
Teacher, I think this is a translational motion.
Translational motion. Mm-hmm. Okay. Is there any other idea? Phạm Anh Khoa.
So I think it's a translational motion.
Okay, thank you. Is there any other idea? Two of us said it was translational motion. I would like to hear one more. Yeah, Đinh Hoàng, Đinh Hoàng, sorry, Đinh Hoàng Dương.
Yes, teacher.
Yeah.
I think a cycloid translation, motion, and vibration.
This is the Ferris wheel. Okay, you are saying that people in the cabin are in both translational motion and vibrational motion. Okay, thank you. Mai Quốc Trung.
Dạ thưa thầy, em xin phép trả lời bằng tiếng Việt là câu trả lời của em là chuyển động thẳng kết hợp với lại chuyển động quay.
Oh, okay, thank you. If it's if possible, please answer my questions in English. This is your rare case to practice your English. But if you want, you can answer in Vietnamese, of course. Okay, whatever you want. But it's okay. Thank you. Actually, in order to know for sure what kind of motion, if you are in a cabin, we will try to do a trick as I showed you. So imagine that you are here, right? You are in one cabin. You draw a line. For example, you draw a line from, actually you can just stand up, right? You stand up and you draw a line from your nose to a point between your two hand, to like the buttock or the or chest, your chest, right? You can draw a line between your nose and your chest, and you observe that line during the motion of the cabin, right? For example, you are here. You are here, for example, right? And you draw a line from your nose to your chest like this, okay? When it is, for example, it is moving in this direction. If you are here, you see that line here, right? The line from your nose to your chest. And if you are here, again, the line will appear like this. You can see that the lines are parallel to each other, right? And therefore, actually, you are in a translational motion. You are not rotating. You are not rotating. You are in translational motion. But it is the translational motion in a circle path. Chuyển động tịnh tiến theo một đường tròn. Ok, chuyển động tịnh tiến theo một đường tròn, chứ không phải là chuyển động quay. Imagine that if that was If that was rotational motion, I think you would never try a Ferris wheel, right? You will be very upset when you rotate. You are not rotating. You are in translator motion. You're sitting like this, and you move, and you are not rotating around, right? Just sit like this. That is translational motion. Okay. Okay. There was several words, kind of introductory of motions and their different kinds of motions and so on. Now we will move on to the most important part, that we will try to describe things, how they move, right? And right here, you see that the approach that we learned in the last lecture, that was the model and the model building process, right? As I said, all we know about nature is models. And in this part, we will study the one-dimensional translational motion, right? At the beginning, we don't care about vibrational, we don't care about rotational. We only care about the simplest form of motion, that is translational motion in one dimension, okay? Uh, as I said here, it means that we have an object and it is moving on a straight line, okay? And our model that we will apply here is the model of particle, hạt hoặc là chất điểm. That is a model. So what is a particle mean? A particle means something very small, right? Very small. In the problem that you are solving. I mean, in your problem, the size of the object can be ignored, right? For example, you have a bike, right? You have a bike. It is about, I guess, nearly 2 meter long, right? A bike. And it depends on which problem you are looking at. Sometimes you can consider it as a particle and sometimes not. For example, if you are moving from your house to the university and the distance is 20 kilometers, then the size of your bike is negligible. Okay, it's too small. And therefore, in that case, you can model your uh, motorbike as a particle. Okay. However, if you are moving from our university and then you move into the Thủ Đức market, okay, and inside the Thủ Đức market, as you know, we have stores everywhere, people working everywhere, and in that case, actually, your size, your bike size is a problem. It cannot be considered as a particle anymore, right? So particle, chất điểm, okay, is a kind of a model, and we apply it when it is when you can ignore the size of your object. We can ignore the size of very, very large objects, even the Earth, okay? The Earth is very large, our house, the home to every, single person, but sometimes the Earth can be modeled as a particle, especially when we consider the motion of the Earth around the sun, right? The orbit of the Earth around the sun is very large, and therefore the size of the Earth can be ignored when you describe the motion of the Earth around the sun. Okay? However, if you want to describe the motion, for example, day and night, right? We are talking about the rotational motion of the Earth about its own axis. In that case, we cannot say the Earth as a particle. Okay. uh, or sometimes our object is too far away from us. For example, you want to describe the motion, you want to describe some galaxy, right? Galaxy, thiên hà, and the galaxy is very far away from the Earth. In that case, according to this distance between the two objects, we can model the whole galaxy as a particle. Okay. So this is yeah. So you can see that the answers here to the question here is that it depends, right? I have a question here, but it is very simple, so I didn't ask you. Your bike, the Earth, the air molecules, and our body. We can model everything here as particle depending on the problem. Okay. Sometimes yes, sometimes not. Okay. For example, yourself, the same. If you want to describe your position in the world or in Saigon, you can consider like, okay, I am a particle. However, if you are sitting in a crowded lecture hall, you are not a particle anymore, right? Okay. In order to describe the kinematics of a particle, yeah, now we are talking about particle, the model that we used. We need several quantities, and the very first quantity is position, right? Where are you? Position, okay? But before talking about the position, we need to talk about the reference frame, okay? For example, I say I am at 2 meters. You cannot, you will never know. So where am I, right? I would say I am 2 meters away from, for example, the podium, or I'm 2 meters away from my desk. I'm in front of my desk and I am 2 meters away from it, right? And therefore we need a reference frame. So what is a reference frame? A reference frame can be understood as a system in which you have the following things: a reference point, một cái điểm mốc, for example, my desk; a coordinate system, một cái hệ tọa độ, right? For example, equation, you have x, y, z, okay? And you have a clock, cái đồng hồ, okay? This is an example, right? You want to describe the motion of a fly in your room. Một con ruồi bay ở trong phòng. I want to describe its position. So the first thing that I have to create my own reference frame, and this is my reference frame. My reference frame is my room with the origin here in the corner. I have x over 1 direction, y going another direction perpendicular to it, and I have z. So I have a system of coordinates, right? And I have a clock, a world clock here, so I can count the time. Okay, so that's done. It's enough for me to describe the position of a fly. And for the position of fly, I would use a vector, right? Because the fly can move in 3 dimensions, so I will use a vector r. Okay, we call r the position vector, or the vector of position. Okay, this is the position of it. Actually, a vector r is equivalent to 3 coordinates, right? X, y, and z. Everyone knows that, right? We know it from mathematics, basic mathematics. If we have a vector in 3 dimensions, it can be written in terms of 3 coordinates, x, y, and z. Right? So this is position of the fly, right? And this position usually is given with the time, right? The fly is at this position at, for example, 12 o'clock, 12:15. Right? So you have the position and the time. The fly is at that position. So the position is defined, right? One thing that you should pay attention to is that we are talking about vectors, right? Vector. So I will remind you that a vector has two characteristics. The first thing is the magnitude, cái độ lớn, okay. And the second thing is direction, right? Direction. For example, I give you the distance from of the fly from the origin. I would say 5 meters. The fly is 5 meters away from zero, from O, right? Then you don't know where exactly it is, right? It can be here or there. It can be in a sphere, right? It can be in a sphere with the radius of 5 meters around the point 0 here. You don't know exactly. Therefore, you need the direction. And the vector R gives you two things, right? The magnitude, 5 meters away, and the direction in this or that direction. So position has vector nature, okay? Position has a vector nature. It shows us about the magnitude and the direction. So that is very important. Okay. However, in this, in this lecture, we start with one-dimensional motion, just one dimension. And in that case, we don't need a vector. We only need one axis, right? Một trục tọa độ thôi. And we would call it x, like this. We have an axis, we usually call it x, right? We have an origin, cái góc tọa độ, which is 0 here. And traditionally, we will define the direction from left to right as positive, right? So if you go to this direction to the right, it's positive. You have +3, +6, and +9. If you go to the left side of the origin, it will be negative. This is our traditional way, right? So, and therefore, if you are given with this axis, you can say, okay, I have a point P located at the position 6, for example, meter, right? And another point Q is at -3 meter, for example. Right? So these are how we describe the positions of particles, right? In physics, usually we will write x as a function of time. This is very, you will see almost everywhere when we talk about position. The position of a particle, of an object, usually is written as function of time, right? Like this, okay? It says that the position depends on time, and when you have time exactly here, you know what time, where is it at what time, where is it at what time, for example, okay? And this kind of motion is called equation of motion, gọi là phương trình chuyển động, right? That is just one way of calling it. The name of it, it's nothing special here, right? The equation of motion is kind of equations that describe the motion, right? If you describe the position of some particle with time, that is one equation of motion. If you have another equation describing the dependence of velocity of a particle as a function of time, you have another equation of motion. And if you have another equation describing the acceleration, gia tốc, that is also an equation of motion. So these are equations that describe the motion of particles. We call all of them equation of motion. Okay, this is the equation motion for position, tọa độ. Okay. The next concept is displacement. Cái này là độ rời, độ dịch chuyển. X là tọa độ, position là tọa độ. Okay. Displacement là độ rời, độ dịch chuyển. Nó là sự thay đổi của tọa độ. Okay. So as I said here, that is the change in position. Okay. And displacement, it is denoted by delta. Okay. Displacement is the change in position. So the change of something, we usually use delta. Để biểu diễn cái sự thay đổi của các đại lượng thì chúng ta hay dùng cái chữ delta. Okay. So delta x means the change in x, the change in position, right? And here you see we have delta x is defined as the final value minus the initial value. Okay, f is the final position, xf, and xy is the initial position. So remember this definition. When you have the change delta of something, it is always the final value minus the initial value and not the opposite. Sự thay đổi của các đại lượng với ký hiệu trong sách của sơ quay lúc nào cũng là cái đại lượng cuối trừ đại lượng đầu. Sự thay đổi của tọa độ là tọa độ sau trừ tọa độ đầu. Sự thay đổi của vận tốc là vận tốc sau trừ vận tốc đầu. Sự thay đổi của chiều dài là chiều dài sau trừ chiều dài đầu. Sự thay đổi của thời gian là thời gian sau trừ thời gian đầu. Lúc nào cũng vậy hết. Okay. So delta of something is the final value minus the initial value. Okay. That is displacement. And again, we have position which has the vector nature. Displacement also has the vector nature. So not only the magnitude, but also the direction. Here we have only one dimension, and therefore we don't use the vector notation here. Okay, and you will see the difference between displacement and distance. Distance là khoảng cách, nó là một cái giá trị dương, nó không có nó không phải là một đại lượng vector. Khoảng cách là một cái đại lượng vô hướng, nhưng mà cái sự dịch chuyển thì nó là một cái đại lượng vector. Phân biệt cái đó. Okay, displacement x and distance, we use d as the notation, right? That is distance. So you see here, delta x by definition, it can be positive, it can be equal to 0, or it can be negative. If xf is less than sy, right? Delta x less than 0. However, for distance, it is the length of something, and therefore it is always positive or equal to 0. It can never be negative. Okay. So as I wrote here, d is a scalar quantity. Cái đại lượng vô hướng, scalar là vô hướng, okay? Đại lượng vô hướng, scalar quantity. And delta x is a vector quantity, một đại lượng vector luôn luôn có liên quan đến cái hàm nghĩa hướng đó. Ngay cả khi nó không được viết với dấu vector, ngay cả khi mình không dùng dấu vector thì nó luôn luôn hàm nghĩa, bản chất của nó là vector. Độ dời như đây, nó có thể là độ dời về phía này hoặc độ dời về phía này, cho nên là chúng ta luôn luôn có cái hướng mà chúng ta quan tâm đến cái hướng khi mà nói đến độ dời. Đó. Okay, I give you an example here. Okay, so you can distinguish between displacement and distance. In the first case, you move from you go from Saigon to Vũng Tàu. Okay, you start from Saigon, and therefore this is your initial position. You have x, y, and then you go to Vũng Tàu and you stop here. So this is your final position, xf. Okay, what is displacement? By definition, displacement is the final minus the initial, and therefore delta x is xf minus xy. And here we choose an axis with our origin here and the positive direction to the right, right? And therefore, xf minus xi is 100 kilometer, right? With a plus sign here. How about the distance? The distance, you can see that is the distance between Saigon and Vũng Tàu. That is 100 kilometer. So in that case, you see they are equal, right? The next example, when you go back from Vũng Tàu to Saigon, now your initial position is here, and your final one is here, and delta x is the final one minus the initial one. The final position is on the left, right? It is smaller than xy, and therefore we have minus 100 kilometer here. And the distance, again, it is 100 kilometer as before. So you see the difference here already, right? In this case, we have the displacement in this direction. This is Saigon, this is Vũng Tàu, this is a vector, right? Plus 100. when you are moving back, your vector pointing in the opposite direction, and therefore the displacement is minus 100. Now, if you go from Saigon, you go to Vũng Tàu, and then you come back, your initial position and final position is Saigon. So they coincide, right? This is initial, and then you come back here. In that case, you see that the distance now you moved is 200 kilometers, but the displacement is 0 because the initial and the final position coincide. Therefore, you have a distance, but you don't have any displacement. That is 0, right? That is the difference between displacement and distance. You should distinguish between them, because when we move on to define the velocity, but we will care more about the displacement rather than the distance. Okay. Now I will talk about several ways that we can present position time dependence. This is very simple. In order to describe the position of some objects or some particle along with the time, we can draw pictures here, right? You use the pictorial way. At the beginning, you have a car. It is at the point A. It has the position minus 60 meter, right? So it is on the left of our origin. And then 3 seconds later, it is at B, right here, right? And 1 second later, it is here at plus 30 meter. And at 5 seconds, it is at plus 60 meter. This is one way. Draw a picture, right? Another way is tabular. You use a table, right, with the value position A, B, C, D at time 0, 3, 4, 5 seconds. It has the corresponding value of position. And this is another way to, actually we are trying to, describe our motion, right? In particular, the position. So we can draw picture, you can use table, you can use graph like this, right? You have a graph like this, and this is X and this is T. You can use graph like this, okay? And as we're talking about graph, I would say that when you draw graph or when you read graphs, please pay attention to the names of the axis and the units. For example, here we have time and the unit is second. Here we have X and the unit is meter. Please pay attention to this. Okay? This is called a position time graph. Okay, and the final one, the a very useful and fruitful way of describing our position is to use mathematics. As I said, mathematics is the language of physics. So you can have kind of very informative equation like this, right? This is an example. If you have a mathematical form equation like this, you can create a graph, you can create a table, and you can draw a picture. However, if you have picture, you have table, you have graph, still you cannot create the mathematical expression. But the opposite direction is okay, right? If you have a mathematical form, you can do everything with it. You can draw a picture, you can make a table, you can draw graphs. So, and therefore, we would use basically the mathematical form. It's very informative. Right? And our one of the main objectives of kinematics is to find equations of motion. Tức là nhiệm vụ chính của cái động học là làm sao để chúng ta tìm được các cái phương trình chuyển động. Ví dụ như cái phương trình tọa độ theo thời gian này là một cái dạng phương trình chuyển động. Khi mà chúng ta có cái phương trình chuyển động như vậy thì chúng ta có tất cả các thông tin cần thiết về cái chuyển động, để mà chúng ta nói là cái chuyển động đó nó diễn ra như thế nào, đúng không? Thì cái mục đích của động học là tìm những cái phương trình chuyển động như thế. Okay, now we have velocity, right? Velocity, vận tốc. Velocity tells us about how fast something is moving, right? For example, you are moving like with an average speed with your bike. I mean, 40 kilometer per hour. That is kind of a speed, right? Or velocity. Okay. So in order to define the velocity, we have to remember that that is also a vector. Right? Always remember that is a vector. Okay. And we will start the definition with an average velocity because it will give you a picture and then you apply it to the more, you know, the so that will be easier for you to start with the average velocity. Cái vận tốc trung bình. Okay? Start with it first. So when you want to denote an average value of something, you use AVG, abbreviation for average, or you can use a bar like this. Okay, we will understand that that is an average value, or sometimes you can use a such bracket. It's called the angle bracket. I don't remember. Maybe the angle bracket or something like that. Okay. So these are different notations to say we are talking about average value. Okay. In my lecture notes, I use the bar. Okay, the bar to mention the average velocity. So by definition, the average velocity is the displacement divided by the time it takes for that displacement. Okay, delta x divided by delta t. Here you see again, delta x is final x minus initial x, and delta t is final t minus initial t. Okay, and here we have another definition, average speed, tốc độ trung bình. Velocity là vận tốc. Ok, nói đến velocity là mình hiểu nó là vector, vận tốc. Tất nhiên là cái cách dùng thông thường nó cũng khá là không thống nhất, nhưng mà ở trong cái giáo trình của Survey á, và trong cái giáo trình mà chúng ta sẽ dạy, và nói chung là trong cái chương trình của lý 1 thì chúng ta thống nhất như thế này. Velocity là vận tốc, và vận tốc thì chúng ta muốn nói đến một vector. Cho nên là khi mà thầy bảo các em tìm vận tốc thì các em hiểu là các em phải tìm độ lớn của nó và cái phương hướng của nó. Nói đến vận tốc là nói đến vector. Có thể trong cuộc sống hàng ngày thì chúng ta, khi mà chúng ta nói đến vận tốc thì chúng ta có thể nghĩ ngay đến tốc độ, nhưng mà ở trong cái nội dung học này thì chúng ta thống nhất với nhau là khi mà nói vận tốc thì hiểu nó là vector. Ok, khi nói tốc độ thì hiểu nó là độ lớn. Được chưa? Okay, so that is the discrimination in our textbook. Velocity is not speed. Okay, so what is speed? Average speed, I use the bar here to say average speed. Average speed is the distance divided by the time. Okay, so as you see, I explained you that displacement is not distance, and therefore they are different. Okay, let's see. Here you have average velocity, and here you have speed, right? Speed is always positive or equal to 0. You don't have negative speed, right? If you are not moving, the speed is 0, right? If you are moving to the left, to the right, whatsoever, you will have some positive speed. Tốc độ luôn dương. Học bằng không? Speed is a scalar, right? Average speed. However, as you see here, we have the definition of velocity, and it involves the displacement, and displacement is a vector, and therefore velocity is a vector, right? So the average velocity can be positive if delta x is positive, it can be 0 if delta x is 0, and it can be negative if delta x is negative, right? So average velocity is a vector, and speed is a scalar, đại lượng vô hướng. Cái này là đại lượng vector. Okay. Again, I will give you an example so you can distinguish between speed and velocity. Okay, Imagine that you are going from Saigon to Vũng Tàu, okay? And our positive direction is to the right. Okay, you travel this distance to 100 kilometer in 2 hours. Okay, what is the average velocity? The average velocity by definition is delta x divided by delta t, and delta x is xf minus xy. It is plus 100 kilometer. When you divide it by 2 hours, you have plus 50 kilometer per hour. Okay, how about the speed? Speed is distance divided by time. So it is also 50 kilometer per hour. Now, if you go in the opposite direction, you go from Vũng Tàu to Saigon, now you have delta x minus 100 kilometer, right? Remember our previous example here, right? You go backward, you are going in the negative direction, and therefore you have minus 100 kilometer here. And now you have velocity minus 50. But the speed still it is positive, right? And if you go from Saigon to Vũng Tàu in 2 hours and then you go back from Vũng Tàu to Saigon, delta x is 0 because the final and initial position coincide. Therefore, delta x is 0 and your average velocity is 0, but the average speed is different. The average speed now is the distance divided by the time. The distance is from Saigon to Vũng Tàu and then plus Vũng Tàu to Saigon. That is 200 kilometers. And the time is 2 hours plus 3 hours, 5 hours, right? So therefore you have the average speed is 40 kilometers per hour, but the average velocity is 0. Okay. So this is something that you should keep in mind. Okay, keep in mind that velocity is a vector, speed is scalar. Okay. And remember that speed is not the magnitude of the average velocity. Chú ý chỗ này này, tức là tốc độ trung bình không phải là giá trị tuyệt đối của vận tốc trung bình. Ok. Bởi vì các em có thể nhìn thấy đây, ví dụ này. Tốc độ thì lấy khoảng cách chia cho cái thời gian di chuyển. Khoảng cách di chuyển được chia cho thời gian di chuyển. Còn vận tốc trung bình thì phải tính được cái độ rời. Thì độ rời, ví dụ như em đi từ một cái điểm đó, em đi loanh quanh rồi cuối cùng em quay lại điểm đó. Thì mặc dù cái quãng đường em đi được rất là nhiều nhưng mà cái độ rời nó vẫn không, vẫn là không. Thì lúc đó là vận tốc trung bình là không. Còn tốc độ trung bình thì tất nhiên là khác không rồi. Lấy tổng quãng đường chia cho tổng thời gian di chuyển. Ha. And now we will study something that we call a position time graph. Cái giản đồ hoặc là cái đồ thị tọa độ theo thời gian. Okay. Position time. That is a dependence of position according to time, right? So if you see a graph like this, okay, what do we know about it? What do we know about it? Look, this is not the real path of the particle. Okay. This is only the dependence of position over time. You got it? The real path is here. Okay. It is only moving along a line. Maybe it is here, here, or here. When it goes back, it is here, for example. But this is the real path. This is not the real path. This is only a line. This is only a description, kind of a function, right? Describing the dependence of position over time. So please remember that. Okay. Tức là ở đây chúng ta có một cái đồ thị tọa độ thời gian, đồ thị tọa độ theo thời gian này. Là cái đồ thị này cho chúng ta biết cái sự phụ thuộc của tọa độ của các cái chất điểm tại những cái thời điểm khác nhau. Vậy thôi, nó chỉ là một cái mô tả toán học thôi chứ nó không phải là cái quỹ đạo của vật đó nha. Đây không phải là cái quỹ đạo mà vật nó đi đâu, nhớ nhầm điều đó. Nhìn này, đây là sự phụ thuộc của x và thời gian. Còn cái vật này nó đi thì thực sự là nó đi ở trên cái đường x thôi, nó đi như nào đó, đi qua đi lại không quan trọng, nhưng mà đây mới là quỹ đạo thực của nó này. Còn ở đây không phải quỹ đạo, đây chỉ là một cái hàm số thôi, mô tả cái sự phụ thuộc của tọa độ và thời gian thôi nha, chú ý chỗ đó. So our purpose here is to show you the graphical meaning of average velocity. So look here. For example, we have at the initial time ti, our particle is at the position A, okay, xy, for example. And at tf, our particle's position is xf, okay. And here we draw the function xt, okay, t. So we can see that the meaning of the average velocity is exactly the slope of the tangent line of the line between them. Okay, so this is the definition: delta x over delta t. Okay, delta x is x at b minus xa, and delta t is tb minus ta. This is delta x. Okay, because xf minus xy, this is this distance. Okay, this is delta x, and this is delta t, tf minus ti. This is delta t. Okay, so delta x divided by delta t is the tangents of this angle, cái tan của cái góc này, đúng không? Tan của góc này. Cái này ở trong toán ngày xưa mình gọi là cái hệ số góc. Hệ số góc ở đây người ta gọi là cái slope. Slope là cái độ dốc của cái đường nối hai cái điểm nào đó trên cái đường cong này. Đó là một cái đường cong này em nối một cái điểm AB, thì em sẽ cái đường thẳng nó sẽ có cái hệ số góc của nó là cái độ nghiêng đó, cái độ nghiêng của nó. Hệ số góc càng lớn này độ nghiêng càng cao. Thì cái độ nghiêng này về mặt vật lý, nếu mà các em vẽ một cái đường cong của tọa độ theo thời gian thì cái hệ số góc hoặc là cái độ dốc của nó thì có ý nghĩa vật lý là bằng với lại cái tốc độ, cái vận tốc trung bình của hạn. Okay. So if v is positive, it means the line AB goes up, right? If v is negative, it means the lines go down, right? Because it go up, if it has a positive slope. When it goes down, it has negative slope. Okay. For example, here between A and B, we have positive slope because the line is going up. If you draw a line between B and C, it is going down, right? It is going down, therefore the slope is negative, right? And the slope is exactly the velocity, and therefore you can say that from A to B, our particle is moving in the positive direction, and on BC it is moving on the negative direction, in the negative direction. Okay. And when v is equal to 0, it would look like this. Okay. Okay. So the slope is 0 when our line is parallel to the t-axis here. Okay. Right. This is upward, negative, positive. If you go downward, it is negative. And if it is parallel to this axis, we have 0 velocity. Another way to see that is just look at the position. If you have a point here, right, and sometime later it is here, is there any change in the position? No. It is still the same, right? If you have a line like this, and imagine that you have M and N, for example, right? So you see that the position xn is equal to the position xm, and therefore delta x is 0, right? And therefore v is 0. We have no change in the position. Yeah. Okay. So the slope, if you draw the graph of position and time, then the slope of a line between A and B, for example, has the meaning of average velocity. Okay. Now we'll talk about instantaneous velocity, vận tốc tức thời, right? So in physics, especially in this course, when we talk about velocity, usually, automatically, we don't think as average velocity. When we say velocity or simply velocity, it means instantaneous velocity. Vận tốc tức thời là vận tốc tại chính xác một cái thời điểm nào đó trong thời gian, chứ không phải là một cái vận tốc trung bình giữa hai cái điểm thời gian nào đó. So if we want to mention average velocity, we will mention it explicitly. Okay. Khi mà nói vận tốc không thôi, chúng ta hiểu là vận tốc tức thời. Khi nào mà thầy muốn đề cập đến vận tốc trung bình thì thầy nói rõ rồi. Also, you can see that average velocity cannot provide enough information. For example, you want from Saigon to Vũng Tàu, you start at 6 a.m. and you are there at 10 a.m., right? And if you only talk about the average velocity, right? You count the time it takes, for example, 4 hours, right? And the distance is about 100 kilometer. You divide the distance by the time. 100 divided by 4, you have 25 kilometer per hour. That is your average, velocity, right? However, when we talk about instantaneous velocity, we mean the velocity at every single moment of time. For example, when you see the traffic light, right, you have to slow down your car, and sometimes you have to stop, right? And your velocity at that point is 0, right? When you see something dangerous, you have to slow down your car, and the velocity is a little bit lower. You see beautiful signs, you stop and check-ins, right? You have 0 velocity here. You have to eat something, or you have to buy some gas, for example. So you see that instantaneous velocity changes over time. And if you want to have an informative picture of the exact value of velocity at every single moment of time, you need instantaneous velocity. And we will try to define it in a mathematical way. We will start the definition of instantaneous velocity using the definition of average velocity, right? How we do that? We will calculate the average velocity using the definition that we had before, but now we take only a short range of time. Okay, we don't take the time from Saigon to Vũng Tàu. We only take a very short time. For example, 1 minute, and we measure the distance, and we divide the distance by the time 1 minute. We have something very close to the instantaneous velocity, right? And then we shorten the time. If we do that, and if the time is now very short, we can say that that is the instantaneous velocity. You see here, we have the point A and B, right? We call it initial and final. And then we measure distance, actually the displacement delta x and the time delta t, right? We divide delta x by delta t, and we get average velocity. But if we let the point B closer and closer to the point A, we will have the instantaneous velocity. Right? And therefore, we define the instantaneous velocity by the limit of the average velocity when the time interval going to 0, right? And by definition, from the mathematical point of view, you will see this is the derivative, đạo hàm of position with respect to time, okay? So velocity is the first the derivation of position with respect to time. Okay, we can use dx over dt, or sometimes you can use x prime t, or you can use x with a dot on it. This is Leibniz notation. This is Newton's notation, for example, right? But usually we will use dx over dt, right? That is, we derive x with respect to t. So that is what instantaneous velocity is. Okay. Mm, I think we should have some break, right? Uh, I give you 10 minutes break, but please during this time type in your full name in the chat box with your student ID. Okay. Tức là tuần trước có rất nhiều bạn là vắng nha. Thứ nhất là có một số bạn vắng vào tuần trước, và thứ hai là có một số bạn là do đăng ký môn học trễ, hoặc là do thay đổi lịch học hay như nào đó mà mới đăng ký thêm vào. Đó. Cho nên là thôi thì thầy tạo điều kiện, tức là tuần trước á, bạn nào mà có lỡ vắng á, thì thầy cũng coi như là các bạn có đi học ha. Các bạn học lớp thầy thì biết là thầy cho điểm quá trình qua cái việc đi học nữa. Tuần trước thì thôi thì tuần đầu một số bạn không kịp nhận thông tin, hoặc là một số bạn thì mới đăng ký sau, thì thầy không có tính trừ điểm. Tuần trước coi như không trừ điểm, bỏ qua. Nhưng mà bắt đầu từ tuần này ai đi vắng là thầy trừ này nha. Cho nên bây giờ điểm danh đi, ghi tên họ đầy đủ với mã số sinh viên vào đi rồi. Ok, nghỉ 10 phút là thầy quay lại ha. Okay, let's continue. So we talk about instantaneous velocity, and now we will try to figure out the graphical, the graphical meaning of instantaneous velocity. Previously, we knew that if we um, draw the graph of position over time, and we draw two lines between a line between 2 points A and B, right? And then the slope of this line, the slope of this line is exactly the average velocity, right? So what about the instantaneous velocity? By that, by defining in the definition of instantaneous velocity, right? You see, we so we have here the dependence of x of position over time, right? Again, this is the real path, not the real path of the particle. Okay, this is only a function, graphical, the graph of a function. Okay. Uh, in the definition of instantaneous velocity, you understand it as we have a point A as the position, initial position, and then we consider a final position B. If you draw a line between A and B, the slope of this line is the average velocity of the particle, right? Now, if you let the B closer to the initial position, you have B prime here. It is closer, right? You have another one, a slope, A B prime. Right? If you keep going like this, the two particles will be very close to each other, and this line, right, will become the tangent, the tangential line, the tangent line here. Okay, and the slope of this tangent line, okay, the slope of this tangent line is the instantaneous velocity. Okay. Tức là các em vẽ đồ thị của tọa độ theo thời gian. Nếu mà lấy hai điểm nào đó thì cái hệ số góc của nó chính là cái vận tốc trung bình. Còn cái vận tốc tức thời thì sẽ bằng cái hệ số góc của cái đường tiếp tuyến, cái đường tiếp tuyến tại điểm đó. Ví dụ như các em tính cái hệ số góc của cái đường màu xanh lá ở đây và thu được cái giá trị là nó, thì đó chính là giá trị của vận tốc tức thời của chất điểm tại điểm A, tại vị trí A, tại vị trí xa và cái vị trí thời gian tương ứng. Đó là cái ý nghĩa hình học của vận tốc tức thời. And when we talk about the slope, right? You have to remember that the slope has dimension and it has units, right? In mathematics, usually we don't have the unit in mathematics when you draw a line like this, right? In mathematics, but in physics, everything have usually it have units and dimensions, and therefore, when you talk about uh, the slope of such lines, tangent line, for example, you have to pay attention to the unit. For example, if you have here time in seconds and position in meter, then the tangent line has the slope with some unit that is meter per second, right? And that is the velocity, meter per second. However, if you have here kilometer and here you have hour, and then the slope will have unit of kilometer per hour. Okay, that is why you should always pay attention to the names of the axis and the unit in physics. Okay. And now we have another thing like instantaneous speed, and usually we say speed, right? When I say speed, you understand it as instantaneous speed. And when I want to say average speed, I will speak it explicitly as average speed, right? And now you see it a little bit different here. Previously, we said that the average speed is not the magnitude of the average velocity. However, now we have here the speed is the magnitude. I mean, the instantaneous speed is the magnitude of the instantaneous velocity. My question, why is that? Why average speed is not the magnitude of average velocity, but instantaneous speed is the magnitude of instantaneous velocity? Can anyone answer it? No one? Okay. Let's see the definition of speed, right? The average speed um, the average speed is the distance divided by the time, right? Delta t, right? And delta t can be large, right? However, when we talk about the instantaneous speed, we talk about delta t going to 0, right? And therefore, for a very short time, we have speed is this one. Because for a very short time, actually, speed is divided. You can write like the limit of d divided by delta t when delta t goes to 0, right? And the distance that the particle travel in such a very short time is exactly the displacement, and that is v magnitude. Okay, so the difference here is in the time interval that you consider the quantity. For average one, that the time considered can be very large, right? But, so during that time, actually your particle can move back and forth, back and forth. But for the very short time, infinitely small time, you don't have such things, and therefore it is equal to the magnitude of the instantaneous speed. Okay. And now we talk about the last characteristic of motion, that is acceleration, gia tốc. Acceleration tells us how fast the velocity of the particle is changing. Okay. Now look again. Velocity tells us how fast something is moving, right? It means that velocity tells us how fast the position is changing, right? And acceleration tells us how fast the velocity is changing. Okay. So that is the similarity that I wrote here. The definition of average acceleration is, again, it's very similar to the definition of average, velocity. And therefore, I do not repeat, too much here. So average acceleration is just the change in velocity divided by the time interval, right? And here I use the x index to indicate that we are talking about one-dimensional motion. Right? We only care about the x direction. Our particle moving along the x direction, therefore we have ax here and then here vx. Okay. And what is the dimension of acceleration? Acceleration has the dimension of velocity divided by time. Velocity has the dimension of length divided by time, and therefore the dimension of acceleration is length divided by time squared, and the unit in the SI system is meter per second squared. Okay. For example, gravitational acceleration is 9.8 meter per second squared. And what is the meaning of this number? What is the meaning of this number? So when I say the gravitational acceleration is 9.8 meter per second square, it means that every second, for example, you drop an apple, right? You drop an apple. After 1 second, its velocity will be 9.8 meter per second. Right? That is the meaning of it. How about 2 seconds? After 2 seconds, the velocity of the apple will be 9.8 plus 9.8, which is about 19, right? So 9.8 meter per second square is 9.8 meter per second. It means that after 1 second, the velocity will be added with an amount of 9.8. Okay? That is the meaning of acceleration. Got it? Again, here I will show you the graphical meaning of acceleration. In this case, we will draw the dependence of velocity over time. The blue line is the dependence of Vx over t, okay? And if you look carefully at the definition, it is very similar to velocity, right? And now, if you take 2 points A and B, okay, and you will see that you calculate the slope, and the slope here is exactly delta Vx divided by delta t, okay? So what does it mean? It means that the slope of this line is the average acceleration of our particle, right? And if you look at a tangent line to the point A, the slope of this tangent line is the instantaneous acceleration. Very similar to the case of average speed, average velocity, and instantaneous velocity, right? So this is also the meaning of a mathematical, derivative. It's nothing new here. I believe that when you study the derivative in high school, many teachers told you about the kind of geometrical or graphical meaning of derivative. Okay. Cái ý nghĩa hình học của đạo hàm thôi. Ý nghĩa hình học của đạo hàm thôi. Tức là nếu em vẽ cái đồ thị của vận tốc theo thời gian thì cái hệ số góc của một cái đường nào đó, ví dụ như em xét hai cái điểm AB, đúng không? Thì ở đây cái hệ số góc của cái đường này nó là giá trị của gia tốc trung bình giữa hai cái điểm này trong khoảng thời gian delta t này. Khi mà vật nó thay đổi, có vận tốc thay đổi là một lượng là delta Vx. Còn nếu như mà các em vẽ tiếp tuyến với cái đường đó tại một điểm nào đó A, thì cái hệ số góc của cái tiếp tuyến đó thì chính là giá trị của gia tốc tức thời. Đây là những cái ý nghĩa hình học chung của đạo hàm. Okay. Chú ý là khi mà chúng ta xét những cái hệ số góc này thì chúng ta đang vẽ cái đồ thị là đồ thị của vận tốc theo thời gian, chứ không phải là tọa độ theo thời gian. Nếu mà các em vẽ tọa độ theo thời gian thì mấy cái hệ số góc này nó sẽ cho các em biết giá trị của cái vận tốc tức thời và vận tốc trung bình. Còn ở đây thì chúng ta có đồ thị của vận tốc theo thời gian, Cho nên các cái hệ số góc ở đây cho chúng ta biết về giá trị của gia tốc trung bình và gia tốc tức thời. Now I have a question. Okay, we have a velocity time graph here, and we will consider four points A, B, C, and D. Now, my question is, what is the sign of AX? It means the acceleration of our particle at point A, B, C, and D. Can anyone answer it? Tô Đức Anh.
Em nói tiếng Việt nha thầy.
Ok.
Dạ thưa thầy là ở A là A nó gia tốc sẽ là dương, ở B sẽ là bằng không, ở C sẽ là âm và ở D là bằng không.
Okay, correct. Thank you. Yeah. So, as I explained here, right? If you look at these points and you draw the tangent line, cái đường tiếp tuyến tangent line, you will have the value of the instantaneous acceleration. If it goes up like this, it means positive. If it goes down, it means negative. And if it is parallel to our t-axis, it means 0. Okay. So at this point 8, actually, we know that it is accelerating. Here we know that, its velocity has a maximum, right? At point B, the velocity has maximum, and therefore we have the derivative equal to 0 here. Okay. Here we have we see that over this time, the velocity of our particle is constant, right? Because from here to here, we have a straight line parallel to the axis t. It means that the velocity is constant. If the velocity is constant, it means no acceleration, right? Therefore, yeah, your answer was correct. Okay, yeah, and as we see here, acceleration is the derivative of velocity with respect to time. It means that acceleration is the second derivative, right? The second derivative of position with respect to time. And that is our connection that I wrote here, right? This is a diagram that is very useful for you to solve problems, okay? So if you have position of a particle as a function of time, right? How do you get the velocity? Very easy. You use the definition, right? Velocity is the derivative of position, and therefore you take the derivative of x with respect to time, and you will get velocity. Now, if you have velocity, you want to find acceleration, take another derivation of vx over dt. You get acceleration. And the other way around, if you have acceleration as a function of time, now you want to find velocity. Now you have to do integration, right? You have to do integration. And similarly, if you have velocity as a function of time and you need to find position, you have to integrate your expression. However, please pay attention to one difference here. When you differentiate, right? Lấy đạo hàm, when you differentiate, you don't need any additional conditions. But when you integrate, in order to have definite integration, you will have to kind of the knowledge of the limits of the integration, and you have to have additional conditions, right? Pay attention to that small difference. Khi mà mình có vận tốc, có quãng đường thì muốn tìm vận tốc thì khi mà có tọa độ, một cái biểu thức của toán học của nó theo thời gian, mình muốn tìm vận tốc thì cứ đạo hàm ra thôi dễ. Có vận tốc theo thời gian, đạo hàm tiếp ra gia tốc. Nhưng mà nếu mà em có gia tốc như một cái phương trình của thời gian mà em muốn tìm được vận tốc thì lúc mà em lấy tích phân là lúc nào nó cũng cần thêm các điều kiện, vì các em biết là tích phân thì lúc nào nó cũng sẽ ra, nó có thêm những cái hàm số tự do, đúng không? Đó, cho nên là thông thường thì trong các bài toán khi mà chúng ta có gia tốc này mà muốn muốn tích phân lên để lấy vận tốc, hoặc là từ vận tốc mà muốn lấy tích phân lên để tìm ra cái sự phụ thuộc của tọa độ và thời gian, thì thông thường trong đề bài nó sẽ có thêm các cái điều kiện biên hoặc là các cái điều kiện phụ và để mình tính cái phần đó, lưu ý vậy đó thôi. Okay. Okay, now I will give you two very basic example. In the first case, okay, you have an equation of motion. Đây là một cái phương trình chuyển động này. Okay, đây là một cái phương trình chuyển động, equation of motion. Because we have everything we need here, right? This is tức là cái mục đích của động học là tìm ra những cái phương trình chuyển động, mô tả chuyển động của vật vậy thôi. Phụ thuộc vào thời gian như nào. Here we have a dependence of x over t, right? Usually it is x is given in SI system, meter, and time usually in seconds, right? Now we have questions. Find Vx at t 3 seconds and find Ax at 2 seconds. Very basic, right? Okay. I will solve this very quickly for you to see. As an example, we will solve first the first question, right? We have x is equal to 4t squared plus 1. If you want to find Vx, right, you have to take the derivative of x over dt, which is 8t, right? And then you put time into it. Yeah. Please don't put time first and then derivative. You have to take the derivative first and then you plug in the number. Therefore, Vx at 3 seconds is equal to 8 times 3, which is 24 meter per second, right? Okay. How about Ax? Ax is actually the derivative of Vx over dt, and it is d over dt of 8t, right? You got it here. And that will be 8. And you don't forget the unit, meter per second squared. This is a constant, right? And therefore you can write Ax at t equal to 2 seconds is 8. Okay, this is a very basic example just to show you the procedure. In the second example, we know that, okay, here you see. In the example, the second example, we have what we have here. We have an equation of velocity, right? We have an equation of motion for velocity depending on time. And now we have to find, firstly, the acceleration. To find the acceleration, it is very simple. You just take the derivative. Okay, Ax is the derivative of x over dt. Sorry, Vx. Here we have Vx. Vx 3t squared plus 2t. Okay. That is 6t plus 2. And therefore, Ax at 2 seconds is 6 times 2 plus 2 is 14 meter per second squared. Okay, the second part. For the second part, you have here, you see, you have the velocity. Now you have to find position, you have to integrate. And usually when you have to integrate, you need additional conditions, right? In order to integrate, you can write, usually you will write the definition first and then you can continue. Let me show you this. By definition, Vx is dx over dt, right? This is the definition of velocity. And therefore, dx is equal to dx dt, right? And now you have integration over dx is equal to integration over vx dt, okay? But when we have integrations like these, we have to take note of the additional condition, for example here, right? So what we write, let me continue this firstly. How do we put these conditions into the integration? Now look, dx is equal to 3t squared plus 2t and dt. Okay. Now look at our condition. When t is 1, okay, when t is 1, we have x equal to 1. When we have t 1, we have x equal to 1. Okay, and we want to find x at 3 seconds. We will write x here. This is what we need to find. And here you put 3 seconds. Okay, you got it? And then you will see we have x minus 1 is equal to 3t cubed divided by 3 plus 2t squared divided by 2 with our lower limit 1, upper limit 3. That will be t cubed plus t squared from 1 to 3. So x minus 1 is equal to 27, right? Plus 9 minus 1 minus 1. Am I correct? That will be 34, right? And we have x is equal to 35 meter. Okay. This is actually x at t is equal to 3 seconds. Okay. I think that what we have. Yeah, correct. That is all my slide for today. Now, what you should do next is to go to our web page of our group, and you will do a quick quiz. Okay. Now I will open the quick quiz for you. Where is it? Wait a minute. Okay. Now you go to the page of our group on the site FHQX. You scroll down to our chapter 2, motion in one dimension. Okay. And you will see, if you scroll a little bit down, you will see quick quiz number 2. You have several questions, very simple. Okay, you do it. You have 10 minutes. You have 10 minutes. So this is the quick quiz, and I will take the, you know, the points that you earn here for the quiz in class. Okay, I saw 6 attempts, 7. Oh, okay. You have 10 minutes. Finish it quickly because the quiz will be canceled at a quarter to 3. 2 giờ 45 là cái quiz này nó đóng. 2 giờ 45 là cái quiz nó đóng. Cho nên là có 10 phút đã vào nhanh, làm nhanh. Để chúng ta tiếp tục. Ok. một số bạn nói với thầy là chưa có trong FHQX đúng không? Có một số bạn là chưa, có một số bạn là thế này, một số bạn là vào nhóm sau, một số bạn là mới chuyển vào. Đó, thì trong số các bạn mới chuyển vào thì có một số bạn là đã viết email riêng cho thầy và yêu cầu thầy là add vào nhóm FHQX. Đó. Còn một số bạn như bạn Nguyễn Ngọc Hà và Nguyễn Minh Hưng, Nguyễn Minh Hùng đây thì có vẻ như là các em chưa viết email cho thầy, chưa có báo cho thầy để thầy ép vào lớp FHQX. Đó. Một số bạn mà vào sau thì thầy không thể cập nhật cái đó được, thầy không biết, ngay ở trên hệ thống cũng không cập nhật, cho nên là bạn nào vào lớp sau thì phải viết mail báo cho thầy là ép bạn vào FHQX thì thầy mới ép được. Để đâu ra hệ thống tự động ép vào lúc mà đăng ký, những bạn đăng ký sớm thì nó tự động ép vào lớp, còn những bạn vào trễ thì người ta chưa ép vào kịp mà cũng không liên lạc với thầy thì thầy không ép được thì là chưa có. Đó, cho nên là bạn nào mà chưa học nhóm thầy mà chưa có trên FHQX thì phải lập tức viết email cho thầy rồi kèm với lại thông tin mã số sinh viên, họ tên để thầy ép vào lớp nha. Còn bây giờ thì quá trễ rồi, cho nên là cái quiz này thôi coi như các em không làm. Đó. Thì cái đó là mình không có kịp ép được rồi nha. Đó, em thông cảm. Có một số bạn thì có báo cho thầy biết là vào lớp này lớp kia nhưng chưa có trên FHQX thì thầy có ép các bạn vào rồi. Còn một số bạn vào sau thì viết mail lại cho thầy, viết mail viết mail cho thầy, chứ còn nhắn đồ trên này các thứ là nhiều hồi là thầy không để ý đâu. Bạn nào chưa có trong lớp thì viết lại một email cho thầy để báo là đấy, để thầy ép vào lớp. Nguyễn Ngọc Hà xin phép nghỉ sớm để lên trường học giáo dục thể chất hả? Ok em. Ok. Và bạn nào, có một số bạn là làm xong rồi đó, thì bạn nào làm xong rồi thì chờ chút xíu ha, ngồi nghỉ ngơi tí. Còn tại vì một số bạn vào làm hơi trễ, một số bạn vào làm hơi trễ thì đợi các bạn đã làm xong luôn là mình sửa bài luôn. Đợi chút xíu. Bạn nào làm xong cứ ngồi chơi tí. Rồi tuần sau là mình học offline rồi ha. Rồi lên lớp thì nó nhanh hơn. Lên lớp thì trao đổi mọi thứ nó thuận tiện hơn là học online.
Dạ thầy cho em xin phép nghỉ sớm để đi lên trường học thể chất được không thầy?
Ok em, ok.
Dạ em chào thầy.
Ok, chào em.
Dạ thưa thầy, em cũng xin phép thầy em qua trường luôn ạ.
Không sao đâu, tại vì bữa nay vừa học online vừa học offline nó hơi bất tiện. Bạn nào mà cần phải lên trường để học thì chứ.
Dạ vâng, em cảm thầy, em chào thầy ạ.
Ok. Rồi đợi xíu cho bạn Phan Tấn Cường làm nốt bài này, rồi chúng ta sửa bài luôn ha. Bạn vào làm hơi trễ một chút. Vào trễ là thời gian không đủ đâu nha Cường nha. Thầy cho cái này nó đóng lúc 2 giờ 50. Cho nên em vào trễ em có 8 phút làm thôi, không phải 10 phút như các bạn khác đâu. Okay, as you can see here, we have all finished their quiz. The grade is nice, as you can see here, right? So that's a good contribution from the point of view of statistics. Okay. Okay. Now let's discuss a little bit. Questions here. For example, let me see. Do we have any 10? Oh, okay, we don't have any 10. Okay, I can take this one. Okay, let's consider our first question. Which one of the following statement is true? If a car is slowing down, its acceleration must be negative. A particle with constant acceleration can never stop and stay stopped. If a car is traveling eastwards, its acceleration must be eastward. Okay. What is true? What is true? Let me do it this way, okay? This way, and we will open. Okay. Yeah. This way, like I don't know. I can't do it. I can do it like this. Yeah. Okay. So let's see, if a car is slowing down, its acceleration must be negative. This is not correct. This is not true. Why is that? Why is that? Okay. So in order to understand better, I would ask you, like, what does it mean? What does it mean when the acceleration is negative, right? The acceleration is negative. It doesn't mean that our particle is slowing down. Okay. For example, you have a car and it is moving from A to B, and let's choose the X like this, and the positive direction is this, okay? And the acceleration is negative. It means that x, ax is in this direction, okay? Negative to in the negative direction. Okay, this is the vector acceleration. You can draw the vector acceleration. It pointing to the negative in the negative direction, and therefore ax is negative. It doesn't mean that our particle is slowing down. For example, your car is moving not A to B, but B to A, right? If your car is moving from B to A and it has direction in the same direction with the velocity, you see that actually it is accelerating. Right? Nó đang tăng tốc nếu mà vận tốc và cái gia tốc của nó cùng 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 hướng. Okay, and therefore, when you have acceleration negative, it only means that the vector acceleration is pointing in the negative direction. Okay, it doesn't say anything about whether it is slowing down or speeding up. Okay. Khi mà gia tốc âm nó không nghĩa là vật đó đang giảm tốc độ. Khi mà gia tốc dương nó cũng không có nghĩa là vật đó đang tăng tốc độ. Mà gia tốc âm hay dương thì nó chỉ nói lên một điều duy nhất là cái vector gia tốc đó nó hướng về phía trục âm hay là nó hướng về trục dương. Nếu mà muốn biết một cái vật nó đi nhanh dần hay chậm dần thì cần phải so sánh cái hướng của vector gia tốc và hướng của vector vận tốc. Nếu mà cái vector vận tốc nó cùng hướng với lại vector gia tốc thì vật đang đi nhanh dần đang nhanh dần. Còn nếu mà cái vector vận tốc mà nó ngược với lại vector gia tốc thì cái vật đang đi chậm dần. Thế thôi. Chứ còn đừng có nghĩ rằng là cái gia tốc nó âm thì là vật đang đi chậm dần. Âm hay dương nó chỉ là cái hướng thôi. Okay. A particle with constant acceleration can never stop and stay stop. That is correct, right? If it stops, it has zero acceleration, right? You can think that when we have acceleration, actually we have some force. Actually, we are not talking about force here, but that is a trick. Right? Acceleration means force. That is the Newton's second law. We learned from high school. Acceleration we have, therefore there must be some force, and when we have force acting on some object, it can never be stopped or stay stopped, right? If a car is traveling eastward, its acceleration must be eastward. That is not correct because the direction of a motion is independent of the direction of acceleration, right? If you are moving in one direction and the acceleration is also in that direction, you are speeding up. If you are moving in one direction but acceleration points opposite to it, it means that you are slowing down, right? Therefore, acceleration can be in this way, that way, for example. Right? Okay, that was the first question. The second question, if a car is traveling eastward and slowing down, what is the direction of the force on the car that causes it to slow down? Right? If a car is traveling eastward, this is eastward, right? And slowing down. If the car is traveling eastward, you know that its velocity pointing eastward. Okay, this is north, this is south. This is west, and this is east. So we have the car traveling eastward and slowing down. This is velocity. If it's slowing down, you know that acceleration must be in this way, right? As I just said, acceleration and velocity in opposite direction, it's slowing down, right? Therefore, this is westward. Correct answer. The next question, when you drive on the highway, are the police more interested in your average speed or instantaneous speed? Of course, this is instantaneous speed, right? You are moving from Saigon to Vũng Tàu, your average speed is 40 kilometer per hour. That is okay, right? You will not be fined. However, in some part of your way, you drive it with like 80 or 100 kilometer per hour, right? And you will be fined. Therefore, actually the police care about your instantaneous velocity. When they check your velocity, it is actually the instantaneous velocity and not the average velocity. And this is our last question, right? Still, we have another one here. So let's answer this question first, and we will come back to this later. What happens to the acceleration and the speed of a ball after it is thrown upward into the air? When you throw a ball upward into the air, you know that the earth will pull the ball down, right? Gravity. And what is the speed of the ball and what is the acceleration of the ball? The acceleration of the ball is g, right? Gia tốc động trường, right? It is pointing downward with the constant value of 9.8 meter per second squared, and therefore the acceleration of the ball is constant. It remains the same, right? How about the speed? Well, the speed of the ball actually it's like it depends, right? When you throw the ball up, right? When the ball left your hand already, right? Actually, it is slowed down because of gravity, right? However, when it fall back into the earth, it will speed up, right? And therefore, here we have two processes going up and going down. And when it's going up, the speed decreases, but when it's going down, the speed increases. Okay, and the last question regard some connection between the graph of velocity and acceleration, okay, which is connected to which, okay. In order to understand this picture, you should remember the definition. So we have like Vx, right, is the here we have B and A, right? So Ax, acceleration is the derivative of velocity with respect to time, right? This is it. And this is how we can find a connection, right? So let's see this picture, for example. In this picture, we have a straight line, right? A straight line. The dependence of V on T is a straight line. Therefore, it has only one slope, right? Which is the tangent of this angle, right? Cái hệ số góc của cái đường thẳng này là một hằng số. And the slope of this line is acceleration. And therefore, with a straight line like this, the acceleration is a constant. Right? Vận tốc theo thời gian là một đường thẳng. Cho nên là cái hệ số góc của nó là một hằng số. Và hệ số góc của vận tốc theo thời gian của cái đường thẳng này, đô thị này thì nó là gia tốc. Như vậy gia tốc là hằng số. Cái nào gia tốc hằng số đó này? Okay. This picture, you see, AX is a constant, right? And therefore, A and E are of the same motion. Okay. The next one, let's look at this picture. From this point to this point, it is similar to the A case, right? So here we have a constant value of acceleration. How about this part of the line? Here you see that Vx is a constant. And when V is constant, acceleration is zero, right? Now look, you have a constant acceleration and then it is zero. And therefore C is in correspondence with F, right? This is acceleration, constant, okay, positive. And here, zero acceleration. Okay. And the last one, B and D. Here actually it looks like a parable, right? A parable. It is a quadratic function, một cái hàm bậc hai, quadratic function. And if you differentiate a quadratic function you will get a linear function. And a linear function is represented by a straight line. Đây là một cái hàm bậc 2, đúng không? Cái hàm bậc 2 nó thể hiện cái sự phụ thuộc của vận tốc của thời gian này. Nếu em muốn tìm gia tốc thì em phải đạo hàm cái vận tốc theo thời gian. Mà đạo hàm một hàm bậc 2 theo thời gian thì sẽ thu được một hàm bậc nhất theo thời gian. Thì một hàm bậc nhất theo thời gian thì nó sẽ có đồ thị theo thời gian là một đường thẳng, là cái này này. Đó. Ok, đấy. Okay, that is everything for today. Now, I would like to remind you that on Thursday, the evening of Thursday, I will give you on our group a quiz to do at home and homework. Okay, and you will have another 1 week to finish it. And please don't forget to do it. Okay, that is all for today. Let's call it a day and hope to see you next week. We will go offline. That will be great. Any other questions? Any other questions? If no questions, I hope you enjoyed my lecture and I wish to see you next week. Goodbye.
Goodbye, teacher.
Okay, goodbye. Goodbye.
Goodbye, sir.
Goodbye. Okay. I will stop my recording. Okay, goodbye everybody. Goodbye everybody. Stop recording.